Hi, I'm Tanja Hayes. Let's learn some more economics. Today we're going to take our Production Possibilities Frontiers, or PPFs. We're going to have two of them, and we're going to imagine that we have two people making two different goods, and we're going to see what happens with that. So we're going to learn about the concept of comparative advantage, which means having the lowest opportunity cost. So we have George and Lois, and they are both able to make toys or bikes, and they have different amounts here on their axes. So we know that George could produce 40 toys or 10 bikes or anywhere on this line. I have marked the halfway spot for each as an example of a place where they could decide to produce if they wanted to. So we're going to ask ourselves, who has comparative advantage in producing toys? So comparative advantage, basically the definition is you have the lowest opportunity cost in it. So that means we got to go through the steps and figure out what's the opportunity cost for George for making toys, what's the opportunity cost for Lois of making toys, and then we'll see which one has the lowest opportunity cost. That person has the comparative advantage, and then we'll take it from there. So let's do the work here. What is George's opportunity cost for toys? So George, opportunity cost for toys. I like to write it out because it gets confusing sometimes. Which one are we talking about? Who are we talking about? Which item? So let's write it down so we know. We're talking about George and his opportunity cost for making toys. So let's just follow the little strategy. We know that he could be making 40 toys, or if he chose to put all his time into the bikes instead, he could be making 10 bikes. So basically, he could give up 40 toys to make 10 bikes or vice versa, but what we're interested in is the opportunity cost for toys, which means we want it down to one toy. What's he giving up to make one toy? So we're going to divide by this toy amount to get that into a 1, and we're going to divide by that same amount here so that we're kind of just reducing everything down. So he could be making one toy, or he could be making 1/4 of a bike. So that means his opportunity cost for the toy is 1/4 of a bike. So that is George's opportunity cost for toys. Whew! Let's do the same for Lois. Same process. So now we've got her opportunity cost for toys. So we're going to look at the same kind of idea. She could make either her 30 toys, or if she so chooses to put all her energy into bikes, she could make 15 bikes. And again, we're looking for the opportunity cost for the toys. So what does it cost her to make one toy? What's she giving up in terms of the bikes? So to get this down to one toy, we just divide by 30, and we divide this by 30. So here we have that she can make one toy or 1/2 of a bike. So anytime that she's making a toy, she's given up 1/2 a bike. So that's her opportunity cost for making a toy. So now we have both of their opportunity cost for toys. And the question is, who has the lowest opportunity cost? That person has the comparative advantage in toys. Remember, we're looking at toys. So what's less, 1/4 or 1/2? Well, that's about 0.25. It's exactly 0.25. That's 0.5. So 1/4 is less. So this is the lowest one. And so this lowest opportunity cost means that George has the comparative advantage in toys. So George has comparative advantage in toys, meaning that when he makes a toy, he gives up less of the other things. So it's relatively cheaper for him to make that item. So what's going to happen is that we're going to have George focus on just making toys. And what we're wondering, though, is who has the lowest opportunity cost or comparative advantage in bikes? Well, we could go through and do all of this, just everything being the opposite here with toys and bikes, divide by the other number, etc. All the math would work out so that the whoever had the comparative advantage in toys, the math will work out through everything's kind of 1 divided by the other numbers, blah, blah, blah. We're going to find that Lois then has the comparative advantage in bikes. That's just how the math always works out. So Lois is going to have a comparative advantage in bikes. And again, if you want to pause and go through the math and do that, you would find that to be true. So what you can always remember is once you find who has the comparative advantage in one item, the other person always has it in the other item, automatically by the power of math. All right, so now we're going to take a look and see what happens if then they each just produce the item of their comparative advantage. So George is just going to produce toys, and Lois is just going to produce bikes. And let's magically clear off some of this stuff from the board real quick. All right, so the board is a little cleaner, so we can put some more mess on there. So we decided that George is just going to make toys. So George is going to make 40 toys, and Lois is just going to make bikes. So she's going to make 15 bikes. So now they're sitting there with just one item each, and what they're going to do is they're going to trade with each other. Now, let's just say that they trade half and half. I'm just giving you that kind of out of the blue. So let's say that each one trades away half of their stuff and they get half of the other person's stuff. So where do we end up then? So let's make a little chart of what happens. So George, he is going to make his 40 toys, but he's going to give half of them away. So he's going to end up with 20 toys. And for that, he gets half of the bikes. So he's going to get 7.5 bikes. So I'm not really sure what that looks like. Maybe it's 7 bikes and a unicycle. But we'll say 7.5 bikes. It's okay. And then we'll take a look at Lois. What does she get after all this is said and done? Same thing, right? Because she is giving away half her bikes, half of her 15 bikes. So she will also end up with 7.5 of them. And in exchange, she's getting half of those 40 toys. So she's getting 20 toys as well. So this is where they end up, and we're going to draw that on the diagrams. So basically, so far to recap, we decided that we figured out who had the lowest opportunity cost for each item, aka comparative advantage. Each person then specializes in the item of their comparative advantage, and then they trade with each other. Now the trading ratio is something that we can calculate and stuff, but for now, I just gave you half and half, and it's going to work out. So that's what we're doing in this example. So now we're going to just take a look at, on these production possibility frontiers, where are these points located? And remember that the production possibility frontier is as much as they could possibly do on their own. They couldn't possibly be out in this range. So let's see. George with his 20 toys and 7.5 bikes. Remember I had put these items, the halfway points on here before as a comparison. And so now, instead of being at the possibility of 20 toys and 5 bikes, he could do that on his own. He's now getting 20 toys and 7.5 bikes. So this is 7.5. We pretend that that's a straight line. So he's outside of his production possibility frontier, which he could not have done on his own. So surely Lois must be worse off then, right? Let's go over here and see. She's going to be at 20 toys and 7.5 bikes. She could have on her own made 7.5 bikes and 15 toys, but now she's going to be up at 20. So she is also outside of her production possibility frontier. So as if through magic, both parties are better off after specializing and then trading. And so the big conclusion here, and this is why we care so much about this, is that in a little teeny tiny example with no trading costs or transportation costs and a lot of other things we're not really talking about, but in this simple example, 2 parties can specialize in the good of their comparative advantage, and they can trade, and they can both end up better off. And that's the magic of the PPF, comparative advantage, and trade. All right, see you soon.